Hello everyone, I'm back with a Figure It Out episode. In my last episode, I was at the Barrett-Jackson Las Vegas 2021 auction, and as usual, there were several physics-related things that caught my attention. One of them was this camera crane. Now, there are several concepts we can examine, and since I'm targeting foundational physics, I thought it would be interesting to explore potential and kinetic energy. So today's Figure It Out problem is: a camera with a mass of 10 kilograms is hanging from a crane 15 feet above the ground. A, how much potential energy does it have in joules? And B, if it happened to fall from the crane at that height from rest, God forbid, how much kinetic energy would it have just before it reached the ground, neglecting air friction? So let's start with what we're given. We know that the mass is 10 kilograms and the distance h is 15 feet. But we want our answer in joules, and the units for joules are kilogram meter squared per second squared. So we must convert feet to meters. So 15 feet equals 4.57 meters. Now for part A, we need to find the potential energy the camera has at this height. The equation is PE equals mgh. So this part is easy. We know the mass, the acceleration due to gravity, and the height. So plugging in all of those variables into the equation, we get PE equals 448.3 joules. And by the way, that's a J for joules, not a bracket. Now for part B, if the camera happens to fall freely from the crane, we need to find the kinetic energy it has just before it reaches the ground. The equation for kinetic energy is Ke equals 1/2 mv squared, or 1/2 times the mass times the velocity squared. But we don't know the velocity. We'll need to figure that out first. Now remember, you have clues. You know the acceleration due to gravity, and you know the distance. We can use one of the equations we learned from the uniformly accelerated motion chapter. We can use V final squared equals V initial squared plus 2 times the acceleration times the distance. Now, you may have learned this equation where they used X or Y to represent the distance. We just need to know the distance in this case in the direction of the acceleration and velocity. I simply use the letter H because that is what I used when I identified our variables. So let's plug everything in. V squared equals V initial squared. We know that it fell from rest, so the initial velocity is 0. Plus 2 times the acceleration, which is 9.81, the acceleration due to gravity times the distance h, which is 4.57 meters. That leaves us with V squared equals 89.66 meters squared per second squared. But be careful, this is V squared, not V. To get V, we must simply take the square root, and that leaves us with V equals 9.47 meters per second. So now we can find our kinetic energy by plugging in our velocity and all of the other variables. So we get Ke equals 448.3 joules. Well, look at there. The potential energy when it was held by the crane at rest is the same as the kinetic energy at the ground if the camera had fallen from rest. Come through, conservation of energy. So that is it for today. I hope you're enjoying your summer. The fall semester is only weeks away. If you or someone you know will be taking university physics in the fall, feel free to share my channel to brush up on your physics and be ahead of the curve before school starts. I'll see you in my next video.